Okay, guys, let's review solving equations and inequalities. For our first problem, our first statement is just the problem itself. And our reason is always the given. So let's talk about what is happening to x. It is being multiplied, then added, then divided, then subtracted. So we're going to work backward to undo all of those. So the first thing we're going to undo is the subtraction, and we're going to use the addition property of equality. The next thing we're going to undo is the division, and we're going to multiply both sides by 4. So the multiplication property of equality. Then we're going to subtract 6 from both sides. That would be the subtraction property of equality. And then last, we're going to divide each side by -2, and our one solution is -33. So the division property of equality. And this equation has exactly one solution. Our next problem. Our first reason is the given. Now, when we're solving equations, we're going to have to clear up parentheses first by using the distributive property. That's the first thing you always do if you have parentheses. So we're going to distribute the 1/2 to get 4x minus 6. So that was the distributive property. The next thing we're going to do is we're going to combine like terms on the left, and then we also can combine like terms on the right. So that was simply combining like terms. Now we have variables on the left and variables on the right, so we always need to take care of the variables before the constant. So I'm going to subtract the smaller one out, but they happen to be the same. So we are going to use the subtraction property of equality. And we get -6 is equal to +12. When you have no variables left in your last statement, and the last statement is false, -6 does not equal 12, then we have no solution. This means no value. If I replace x with a value, there's no value that would ever make the left side equal the right side. Okay, our next problem, we have the square root of 3x minus 9 equals -6. The reason is the given. Now, x is being multiplied and then taken the square root and then subtracted. So we're going to work backward. So we are going to add 9 to both sides. And this gives us equal to +3. So this was the addition property of equality. Next, we got to get rid of the square root. So we are going to square both sides. So when I square both sides, square, the squaring undoes the square root. So I'm left with 3x equals 9. So this was the squaring property of equality. And then the last step is to divide each side by 3, and my one solution is 3. So that was the division property of equality. So exactly one solution for this equation. Our next problem, the given, we put a number 1 for our statement number 1. And as you can see, we have variables on the left and the right. So I'm going to subtract out the smaller coefficient. So 2x squared, I'm going to subtract from both sides. So that was the subtraction property of equality. So now we have subtraction, multiplication, and squaring. So I'm going to undo the last thing. So I'm going to add 8 to both sides. So that was the addition property of equality. Now I'm going to get rid of the division and divide both sides by 2. Again, the division property of equality. And then we're going to take, so I have x squared is equal to 9. I'm going to take the square root, and when I take the square root, I need the positive and negative. Taking the square root under squaring, so I get x is equal to a positive 3 and a negative 3. So that was the square root property of equality. So this has exactly 2 solutions, because when I square a negative 3 or a positive 3, I get 9. So this has 2 possible solutions. Okay, now let's get into solving inequalities, which is just like equations. And so we're going to solve graph and then notate. So I'm going to distribute 2/3 to 12x plus 6. So I like to do this shortcut. 3 goes into 12x 4x times, and then 4x times 2 is 8x. 3 divides into positive 6 2 times, and 2 times 2 is 4. If you don't like that little shortcut, you can do it the long way and multiply straight across, and you get 24x over 3, which is 8x. Now we need to isolate x. We're going to subtract 4 from both sides. We have 8x is less than or equal to 8. We're going to divide by 8, and x is less than or greater than, less than or equal to 1, I should say. Let's graph this. Our solution set is either equal to 1 or less than. When we write an interval notation, we write it just like we see on the number line from left to right. So we are focused on this part of the number line. That's the solution. So interval notation is from negative infinity to 1, and 1 is included. If we want to write this in set builder notation, French curly bracket, x is an element of the real numbers such that x is less than or equal to 1. Our next example, we are going to undo the -6. We're going to add 6 to both sides. We're going to bring down x divided by -3 is less than or equal to 10. We're going to undo division by multiplication. So we're going to multiply both sides by -3. The -3 cancels. I'm going to put a big star to remind myself that since I multiplied by a negative, I have to reverse the inequality. So our number line, when we graph our solution set, our boundary number is -30. It is -30 is included as part of the solution, and then all the numbers greater than -30 as well. So again, when we do interval notation, we're only focused on the graphing. The shaded part, so the least value is -30. It is included, so we use a bracket. So if you have the equal sign, you're going to have a bracket. comma for all the values in between, and then the other boundary number is our infinity, which can never be included because we can never reach infinity. Set builder, x is an element of the real numbers such that x is greater or equal to negative 30. Okay, let's take a look at a third one. This time our x is on the right side. So if you like, we can flip this totally around. Now look, the inequality is pointing to the x side, so it still has to point, so make sure you flip the entire thing around. We're going to subtract 8 from both sides. We get 2/3 x is less than negative 12. We are going to divide by 2/3. Dividing by 2/3 is the same as multiplying by its reciprocal. Our 2's cancel, our 3's cancel, so x is less than negative. 2 divides into negative 12, negative 6. Negative 6 times 3 is negative 18. On the number line, the solution set looks like this. It is an open circle and shaded to the left, so my solutions are from negative infinity up to negative 18, not included. Set builder, x is an element of the real number such that x is less than negative 18. Let's do a couple of compound. So this is OR, so I'm just going to solve these totally separate. So we're going to add 6 to both sides. We have 4x is less than or equal to 12. We're going to divide by 4, and my solution can either be greater or equal to 3, or we're going to solve this. We're going to subtract 4. We have negative 2x is greater than 4. We're going to divide by a negative 2. We're going to flip the inequality around. So our solutions can either be this or this. So let's graph this, see what this looks like on the number line. So let's just do the negative 2 here, and then we have 3 here on the number line. For this one, it says x is less than negative 2, and it's not included. Or the values can equal 3 or be greater. So let's do interval notation. On this end, we have negative infinity, comma, negative 2, parenthesis, union. We're going to unite this solution part along with this one. And over here, 3 is included, and then it goes up to positive infinity. Set builder, x is an element of the real numbers such that x is less than negative 2 or x is greater or equal to 3. Let's do one. This is an and statement where both conditions have to be met. So we have a middle part, a left, and a right side. So what we do to the middle, we're going to do to the left and to the right. So we get negative 12 is less than or equal to 2x. That's less than 22. We're going to divide each term by 2. We get negative 6 is less than or equal to x, less than 11. We have negative 6 as a boundary number and positive 11. X is sandwiched between, it's greater or equal to negative 6, but at the same time, it is less than 11. So here, our interval notation, the least number it can be is negative 6, and it's included, and it goes up to 11, but does not include it. Set builder, x is an element of the real numbers such that negative 6 is less than or equal to x, which is less than 11. And I hope this helps.